Hello guys, this is Ved here. Welcome to my YouTube channel. So this is going to be my statistically third video, but those two videos were very basics, and it was since 1.5 year ago. So because of lot of the things, I was not able to upload the videos because some personal circumstances, like in my marriage and then some health issues. So from past 1.5 month, I was doing R&D on different social platforms, like different medium platforms, and like on YouTube, that what are the contents currently it's going on, and what actually it is lagging as per the demand in market. So what I understood, that generative AI. So this field, it has right now in too much demand, and the contents are not systematic on any of the YouTube channel or any of the platforms, learning platforms. There are few contents, but not systematically. And but this, if you nowadays, if you go any of the job requirements on any of the job portals in area of NLP, they will definitely ask you some knowledge on generative AI, like LLMs, works on the LLMs, like large language models. That have you worked on large language model? Have you used a pre-trained large language models, or have you hyper-tuned the large language models with the different data sets or for the different use cases? So, so again, dedicatedly, I will start the videos from the 2nd October. 2nd October. Uh, then probably what I'm going to cover it today, some environment setup, that how we can make a setup in our system for learn this generative AI and LLMs. And then after, what would be the contents I'm going to cover. So this is going to be the rough today, the contents. Again, few more things is going to be added as per the time. So for that, the one thing, which is 2 points which I want to focus here in today's video, and which is mandatory. Your system must have the GPU. Your system must have the GPU. If not, then you might can prefer a Google Colab paid version, or if you have a cloud. But cloud is not needed as of now. If we can go ahead with the Google Colab paid version for 1 month, Colab paid version for 1 month, for 1 month. Then after, definitely this can solve the issue if you do not have the GPU in your system. But if the GPU you have, that would be great. So if you use Colab paid version, it provides the very strong GPU and the faster GPU. And in terms of, again, this cloud, definitely we are going to use either AWS or GCP, because we will see that how we can deploy the model on the AWS or the GCP. With the time, might be I will add both the cloud, but probably I will start it with the GCP, and how we can use the different functionalities of the GCP, and how we can use the pre-built Docker images, and how we can customize Docker images we can use to train our model to create the instance and all those things, and model versioning registry and all those we will try to understand. And the second point, to follow this specific playlist. This is for those who knows uh, basics of machine learning and deep learning. at least they should have a knowledge of basics of machine learning and deep learning, not very advanced level, the basics of, because I'm going to cover these things on very basics. So like that. Now what is most important here to cover, what exactly the things I'm going to cover. So just a minute. So content, what are the contents or the syllabus for this specific playlist. This playlist, probably I will name it with the generative AI. So the first thing is a very basic NLP use case. Very basic NLP use case, such as we can take here sentiment analysis. Very basics. In that, the two library which we will use, NLTK and Spacey, these two. For this we don't need any what I can say, any of the like GPU and all those things. We do not required in that. Okay. Now the second, so here in this we will use basic very basics in a deep learning model. Maybe it could be the simple RNN or the LSTM, and we will try to understand some. We will not go the in very depth, because this playlist I am focusing on for the working professionals who actually wants to work on those on this algorithm. And definitely though I will cover that much of content that you can answer it in the interview as well, that how exactly the LSTM and the RNN works. So with the hierarchy, that what was the drawback in RNN, so that the LSTM came in scenario, all those things. Then again I will take the same use case and will try to solve with the architecture which is called transformers. That how we can use the transformers for our NLP use case. Like in transformers, again we will try to understand the architectures of what is positional encoding, what is positional encoding, and the second is what is self attention, and the third is multi-headed attention. What is multi-headed attention? These three things from the transformer, which is much needed as per the interview, but not as per working wise. Transformers, how you can utilize that is very big, not so huge. And then after some pre-trained transformers, like different architecture of bot, okay, and robot, electabot, and all those things. So there are multiple, okay. So those are pre-trained, and then again after that we will move to those LLMs. Now this LLM would be divided into two parts again. One is pre-trained pre-trained, we will use pre-trained LLMs, and here we will use custom train LLM. Now in case of pre-trained, we will use the Hugging Face API. I'll show it today that how Hugging Face website and from how we can use that. And the custom training which is required because those LLM models, whatever people had built or the organization had built, so they built it for the generic work, like not some any domain specific work. But if suppose we want to utilize those LLM for our some domain specific work, so for that we need to train those LLM. So the architecture will be same. There are multiple ways again to train this LLM. So those all things we will discuss. What are the multiple ways, some PEFT and all those things. So those things we will try to understand that how we can train the model. So these are the basics. But before to this, the one thing is very important is try to understand about the setup, how we can do the setup. So these setup contents are for only who have a GPU in their system. If you have a collab, that you do not have to do any of the setup. Whatever the hands-on will see that you have to do. But if you have a GPU like any GTX or RTX, okay, any if suppose 30 series RTX or the 60 series RTX, 3060 36 series and the 40 series, whatever it is. So in 30 series it is 3040, 3060, and the 4010 and the 4016 is there, I think, which has this RTX is from the NVIDIA. So how you can make a setup by using this. So this setup is required, and then how we can use this GPU in a distributed manner. Distributed manner as in, see, that suppose this, so we know these LLMs are quite huge. These are like 1 GB, 2 GBs model it is. So if we have to train, the parameters are in billions, thousands of the billions and millions. So to train those parameters, you cannot train on a very basic machines on CPU. It requires a GPU. And again in the GPU, why actually the GPU needed? Because GPU provides you the multitasking, multiprocessing. Means there are something work which will come like this if you have this model and there are multiple steps, but these two steps are not dependent. If you have one GPU, it will train it sequentially, but if you have two GPU, this part of the, if you have divided your single GPU into two part, so one part is will train this and the other part will train this. So this is how the distributed will work. So this will reduce the time and make the training faster. So this is how the distributed part works. So today we will even try to understand. I'll show that how exactly you can divide your single GPU into multiple. There are many systems or the workstation you can make with the multiple GPU, but if someone has the one GPU with 4 GB memory, 8 GB memory, or the 12 GB, so how we can distribute those GPU memories into different memories. Okay, and then, so how we can set up this. And if suppose if someone has a GPU and they are not able to install in their system, so how we can install those GPU, how we can use this GPU using the Docker images. Docker image. How we can use the Docker image? In this, you have to just simply pull the Docker image from the Docker Hub, and you can start using that. In that, you don't need to do installation, because in this GPU installation, sometimes it required some Visual C++ packages to be installed. But if it is not, then do not have to worry. You have to use the Docker images. From there we can run the GPU in our system. Now, apart from this, if you are using a paid version of Collab, then this all setup is not required. We'll directly use this distributed part, that how we can distribute the Collab. So now, so these are the things. And then again, the last is here some project on LLM. Again, in case of project on LLM, today I cannot say it that what project I'm going to cover, but definitely 3 to 4 major projects which is going you can use, and you will get the direction that how those things are helpful for your interview and all those things. So and then for now, let's understand what I said, that for the Hugging Face, that how Hugging Face and the large language model actually looks. So this is the Hugging Face website I'm opening. So you can see that this is the Hugging Face page. This is home page, and probably 1 second, let me, yeah, here it is. So if you can see this is the Hugging Face page. Okay, and now there is model, the data sets and all those things. So now this is the different models by the companies. Okay, and we'll also try to understand that how we can build our own model and we can push into this Hugging Face hub. Okay, Hugging Face is just unlike in GitHub. You have this is Hugging Face is also a repository where, and here you can see there are the different use cases like feature extraction. Feature extraction like an image from the image, if you want to extract the feature. Image to text, if you have some image and you want a description or the captioning for that image, so you can use this kind of model. If you will click, those all model will come. Okay, so like visual question answering, like document question answering, from text to video, text to image, like if you write some text and it will convert into some image using that. So there are natural language like table question answering. So we will I'll show how we can use this model. Like table question answering is like we can just pass our table to this model, and whatever information we want, for that we do not have to write the code. We have to write a simple English, and this model will understand and it will give you the output. You do not have to write any pandas query, SQL query, or any language, whatever you want. So it will give, and it will give with very good accuracy. And there are a lot many, like in tabular classification and the regressions and the reinforcement. So I haven't worked much in the reinforcement too much and in the robotics, but I'll cover it more in the tabular, in the text language like this one, text generation, those all parts we will cover. And here you can see the data sets, whatever the data sets, there are a lot many data sets available. So you can use, if you will go to the here directly on the data sets part, these are the data sets. You can, any of the data sets you can open, and you can try to understand that how those data sets. So the data set viewer is not available for this, so this is not available for this data set. Okay, but there are not many. 1 second, data set, any of the data set is sort by trending. It is sorted with the training most download. Okay, like this has the most download, 7.82 million. So if it is 7.82 million, yeah, you can see some, this is the data set. Okay, so this is the training data set. Also this has only training data set, not the, like there are multiple, so there are 15k records for this. Okay, so we will see that how we can use this all for our uses. Okay, now let's jump to the question which I was saying, that how we can use that. So if you can see my screen here, this Google Colab. So how we can use? So first we need to understand that how we can see whether you have a GPU and what. So you have this simple command NVIDIA-SMI. You have to run this, and if you will run this, see, it will exactly tell you here this is your GPU. See this. So I have the GPU of RTX 4060 series. So so let's see it with the Python, that how we can use these all and understand. So first let's import here. Okay, so the first thing is to get the installation, that how we can install TensorFlow GPU in Windows 11. So this is Windows 11. So we'll go to the official website on that. One second, this is not that website. One second. So you can see it here, TensorFlow GPU. One second, where it is the installation? TensorFlow GPU. Installation. Use a TensorFlow core. Here it is. TensorFlow installation. So this is so if you have Windows 11, so the first thing what you have to do, you have to install Python 3.10. But basically once when you will install the Python 3.10, let me show it to you one thing. Once you install Python 3.10, actually it will install 3.10.13. So you have to what are the steps? So first you have to create a virtual environment, virtual env with any name you can give in the Python version of 3.10. When you will give 3.10, actually 3.10.13 it will install, so that's fine. And then after, once it will install, so you have to activate the virtual environment. You have to activate that. Once it will get activated, then what a step you have to follow? You have to again let's come to the documentation, right? You have to install this Conda install, Conda Forge, CUDA toolkit and CUDA CUDNN 8.10. This directly you have to. So I'll paste this link in the YouTube, the description, and see here. It is saying that if you have a TensorFlow greater than 2.10, it is not supported GPU on Windows native. So you have to run this command again in your activated environment. So it will take little bit time, depends on the internet speed. Almost 600-700 MB file it is. So it will install the TensorFlow, and then after you can easily access the GPU. So I will show the steps that how you can do that. So you have to simply write a command like this: conda create virtual environment, conda create -n, and you have to give any name like tf GPU. Okay, and you have to write python equal to 3.10. this is the first. Then you have, this is the first step. Second step, you have to write conda activate your tf GPU. In your terminal you have to run these all commands. Once it will done, you have activated this, then simply you have to follow this step. Then after you have to run this command in your terminal, and then this command. That's it. It's done. And then simply you have to go and use it. You have to open, and once like this is the way. If you have activated it like this, so if TFGPU will get activated, so TFGPU will shown it here. And then after you have to write here Jupyter space notebook, and you have to hit the enter. And make sure once you have installed, you had installed the Anaconda, it should be in your environment path you have added while doing the installation. If it is not, then you have to manually go in your virtual environment and you have to add that in a path. I think that's very simple. While installing, it will ask at one step that add Anaconda in your virtual environment. So this is how. So now I have opened this. So now if you have to check that whether it has the GPU is working or not, so first you have to import the TensorFlow as TF, and now check the version of this TensorFlow. You can see it is 2.10, which I had told you. Now if you want to check that the GPU is there or not, if you want to check, so for that what you have to do, tf.config dot, I'm using tab here, list of physical devices, and let's run this. So you can see it here, it is showing this one CPU is there and one GPU is there. Their indexing starts with 0, so GPU 0 means that one GPU, and then 0 1 like that. And if you want to see only the GPUs, it has just in simple, you have to write here GPU. That's it. You can see only it is. And the what is the logical and the physical? So logical are those devices actually which generates the thread. Okay, so how many logical devices are there? Let's see. So you can see there are two logical, CPU and the GPU. But in GPU, how many? If suppose we are using the GPU, so in GPU, how many logical devices are there? If you just put it here, GPU. Sorry. So it is saying only one. So how we can make the more logical devices? Now, if you want to see what are the memory of your GPU, okay, what is the memory? So for that you have to import or first install one library, subprocess. So these libraries you can directly install, like pip install subprocessor, like that. And how you can use it, let me and see this. Now let me run this. See, it is saying almost 8 GB of memory of my GPU. Okay, now once we understand it, how many GPUs available, how many things are available, now let's try to understand about that, how we can perform the tasks. Okay, now let's try to understand this. So we have total 1 GPU with 8 GB memory. Now what I'm trying to do it here, you can see set logical device configuration. The logical devices configuration, so the GPU of the zero, matlab the single GPU, means the single GPU I'm using the first, because since I have only one, so the first GPU. If you have a multiple, so you can use the GPU 0, 1, 2 like that. So this is the 0th GPU I'm using, and that GPU is of 8 GB. But what I'm doing, I'm converting this into 2 by I just want to use 1 GB and 1 GB. I want to use only the 2 GB of the memory, and with 2 threads, one thread of 1 GB and another logical thread of 1 GB. Okay, now let's run this. Here it is saying that cannot be because we have already initiated, so we have to just simply restart this. Okay, and just import here, because here these all are we already inserted. Now if you will run, it can easily do that. Now see, here it is saying 1 physical GPU but 2 logical GPU now. And how we can see this 2 logical GPU? So you can see it here. Now I will copy this and paste it here. See this now. Now earlier we had here only 1, but now we have 2. So how we can use this all? Okay. So we can even check that is it the build with CUDA or not. So the CUDA is the NVIDIA package. You can see, yes, definitely these are the builds with CUDA. Now here what we want to do, I actually want to check how we can train the model. So it is simply what I'm trying to do here. So these all are the GPUs. You can see it here. Here logical devices GPU. So list of all logical devices of the GPU I'm taking, and if not GPU, it will throw the error here. And if it is, there is something called mirror strategy that we will discuss in depth in coming classes. But here just understand how many mirror strategy. Mirror means you can understand the replicate strategy I'm doing, and how many times the length of GPUs, and how many logical GPUs are there? 2. If you run this, I had already shown it above, it will give this 2. So this 2 times, and it is only taking the GPU. And with strategy, so these all are the strategies. So in the TensorFlow, I'll tell that what exactly, but as of now just try to understand that how I can run on both the logical GPU. And this is just a model building part, how I build. And here I am declaring the dataset. So the MNIST dataset I'm using, this as simple as, very simple, just for an. And here I'm splitting. And how we can convert a dataset into tensor dataset, and with the batch of 64, what are those uses are there, those all things. And this decorator, we definitely have to decorate our train step with the TF. And this is a reduce mean in TensorFlow, just it's a perform the mean it will take for the categorical cross entropy, this loss function which we are using. And here it is to find the gradient descent. For the gradients, it will trying to find it out, and the sparse categorical accuracy. So, and this is returning these 2, mean of the accuracy, because since we have a 2 GPU, so if on one GPU, if we get 80% as an accuracy, and on other we got the 70%, so what would be the final accuracy? So it will be definitely the mean of the both 2. And this is the optimizer. The epoch here I'm taking 5. So let's reduce it with 3 just to understand here. And now let's run this. So here you can see it here. GPU 1 and the GPU 0 and the GPU 1, both are being used. Okay. Yeah, now see, for the epoch 1, this is the accuracy. We will go in detail, um, complete details in this, every step by step, that how I distributed it and how I ran it. And the same thing, if you do not have a GPU, you can try it on your system, that how it is going to work, and how much time it is going to take, and how the performance is getting difference here. So in 2 it is giving 96, in 3 epoch it has given 97%. So it has only 3 epoch and it has given the 97%. So you can try it, that how it all. And now if suppose I want to check that how much memory has utilized till now, how much memory has utilized till now. So if I just paste it here and use the, so this is in the MB. So if we will divide by 1024, it will be in the GB. So almost it's not much accurate, but almost closely to the 2 GB that entire memory had used. Okay, so this will be the memory which has utilized till now. I'll show you that if I will just restart this and kernel restarted, so it has already deleted everything. Now again, if I will run, let me just run this modern import part and let it run. Yeah, now let's check that how much memory had utilized here. You can see it's saying 259 MB, because I have not even cleared the output. Let me clear the outputs, because it was using because of the output. And now run it, and here I want to check the GPU memory. So maybe some cache was there, because of that it is showing. So it is very less. So 259. So you can see it when I had used it at that time, how much memory it was showing, and now how much it is showing. So this is how it work. Okay, and so yeah, this is how you can make perform a setup. So, and this is the link. You can copy it from this screen as well, while watching the video. So 1 second. Yeah, this the simply this one you have to open it to follow this step, and definitely, and that you need to go to the Windows native and you have to follow, and make sure always your Python is version 3.10. It will install 3.10.13, and then run these two commands. You have to create a new virtual environment with Python 3.10. Run this command first, and then this command, and then after you have to just check this here by understanding here the GPU. Once you will run this here, probably it should come, and if it is not coming, then in the next video I will tell that with the Docker how you can do that. Okay, so you do not have to worry if you are facing. So this is what exactly I wanted to inform, and these are the contents which I am going to cover here. The NLP transformers, pre-trained transformers. Okay, these are the pre-trained transformers. I'm going to cover the large language models. Okay, the pre-trained and the custom, and they are the setup of the GPU. So the basics, how you can set up that, and the Docker images again, and this again those cloud, that how we can do that those things also. Okay, and I'll keep on adding that what extra things according to the market I will keep on adding that. So thank you, and keep learning. Okay, and this is actually I have not much experience on uploading the videos and the content, so probably I would be needed some serious comment for the content of my videos, that how I can make it more representative to you guys, and I will try my best to make it more better with the time. Okay, this video, so that you can get very you will not feel bored while learning this also. Okay, thank you guys, thank you so much.